Hello Physics 1 students. If you're watching this video, that probably means that you're getting ready to start Lab 4. So you can see I'm here on the Physics Lab repository page, and I'm going to click on Remote Instructions. Okay? And you can see up at the top here that there is a simulation that you're going to run. That's actually the tab I just closed, but I'm going to open it. Okay? And you can see when it opens, it automatically has the intro selected. You're going to want vectors, and you're actually going to have to click it twice. So when I click it, that selects it, but then when I click it a second time, that starts the simulation. Okay? So if we go back to our remote projectile instructions, we can scroll down to step 2, where it tells us how to set up the experiment. So you want to move the cannon up to a height of 5 meters and set the initial speed of the projectile to 10 meters per second. Okay, so I'm going to click on this plus sign here and drag my cannon up to 5 meters. And then I'm going to set my initial speed to 10 meters per second. Now you can drag this over or you can use the arrows. Okay, so now we're all set up. If we look at the instructions again, we can see that we're going to start at an angle of 0 degrees. I mean, I guess technically you don't have to, but I would want to methodically go through in order. So I'm going to now set my cannon to 0 degrees. Okay? And then all I have to do now is click this red button that looks like a cannon firing, and it will launch my projectile. Now, the way that this is going to work, as you can see in the table here, is each lab partner is going to measure the distance of the range, okay? So you're going to record for partner 1, partner 2, partner 3. Now, if you're one of those groups that only has 2 people, then you're going to need to split the duties for partner 3. So I would recommend that partner 2 maybe does the second 5, okay? And then partner 1 maybe does the first 5, or vice versa. You know, you have to do 10 recordings, so it's easy to split that 50-50 for partner 3 if there are 2 of you. Okay? So the way that you're going to measure the distance is you're going to take this measuring tape here and you're going to drag it down and you're going to do the best that you can to line up the vertical plus of this with this vertical line here, because this plus here is showing you what the launch position is. And so we want this plus to be lined up essentially with where x is equal to 0, which is represented by this vertical line where it would intersect the y-axis, but really anywhere in space, you know, is where x would be equal to 0, anywhere that this line intersects in space. Okay, so what I'm going to do is I'm going to drag this out and measure how far it went. So that looks to be about the landing position, but when I look at this, this looks a little cockeyed, so I'm actually going to move this up a little bit and then I'm going to readjust so that I can get maybe a straighter line. Okay, so that's looking pretty good to me, and I actually didn't change my measurement at all, so that's kind of cool. So I have 9.17 meters. So I would go into my Excel document and I would record 9.17 meters. Now say partner 2 comes along and they shoot and they, let's say they line it up with this line here. Okay, and they feel like, okay, maybe that's closer to how far it went. So they get 9.12 meters. Okay, so then they record 9.12 meters, and now let's just say that person number 3 comes along and they measure and they get 9. Let's see if we can get a different measurement. 9.22 meters. Okay, just for example. Let's say they do that. All right, then to get the average, we're going to do equals and then type in average. And then we'd highlight these 3 values and hit enter. Now, because we use the formula B3 to D3, well, average of B3 to D3, we can actually drag this down so that later on, when we get all of our data points, that will automatically calculate the average over here. So now let's say that all of our lab partners have done their part and we've collected all of our data. We've got all of our averages. Now what we have to do is we have to create a graph. So let's look back at the instructions. Okay, so number 6 says plot a series of values as a scatter plot of average range versus angle. Remember, the first variable is the vertical axis. Okay, so that means that we're doing y versus x. That's how we always title our graphs. So y is going to be our average range and x is going to be our angle. Okay, so one thing I want to mention before we get into graphing is, let's just say for the simulation, say that you run this a bunch more times and you fire the cannon and it starts getting really messy, okay? If you hit this eraser here, this will erase all of those shots. So that way, if it's starting to muddy the waters with doing your measurements, you can always just erase them. As long as you've already measured them, it's really not a big deal to erase them. So I just wanted to let you know that that tool is there. So you're not firing them and having trouble measuring, and you don't realize that you could just erase them and then it would be easy to measure. Okay? All right, so let's get back to the scatter plot, so average range versus angle. Okay, so if we go to our data set, I'm going to click out in the middle of nowhere and then do insert and scatter. So just to remind you, the reason I clicked out in the middle of nowhere is because if I click too close to the table, it'll start to grab values and maybe not the ones that I want. Okay, so I click scatter, and now what I'm going to do is I'm going to click select data. Okay, that's under the design tab. So I click select data and I click add, and now I'm going to give it the name that we've been told to give it. So average range versus angle. So as we talked about, the x values, those were our angles. So I'm going to highlight all the angles. Then for our y values, those are our average ranges, right? Y versus x. So that's these guys right here. So then I click OK, and I click OK again. And now you can see I have a graph. Now I want to go to my quick layout and make sure that I add in my axes. Okay, so that first quick layout is perfect. Okay, so you're going to want to title your y-axis as average range, and that's in meters. And then you're going to want to title your x-axis as angle, and that's going to be in degrees. Okay, and you can use the symbol. I was just too lazy to go get the symbol. The last thing that you need to do is add a trend line with an equation. So you just right-click any of the points, click Add Trend Line, and then you can see linear is a really poor choice, and it does say in the directions to use polynomial order 2. You can see that fits beautifully. And then we're going to display equation on chart, and then that's it. And you could leave it this way, but personally, since this legend doesn't really tell me anything I don't know already, I usually get rid of it so that I can have my graph take up more space. And then, because I'm a little OCD, I try and center my equation and everything. But that's all you need to do. You don't need to mess with any of the variables in the equation. This graph is done. Okay, so now let's move on to table 2. So in table 2, you can automatically fill in that your height is 5 meters and that your actual initial speed is 10 meters per second. And then you can see over here that I filled in my position equations already for y and x. Now let me explain these position equations. So y of t, so my position in the y direction as a function of time, is equal to negative 4.9 t squared. That's of course gravity. I'm defining down as my negative direction, so that's why it's a negative 4.9 t squared, right? Because this coefficient in front of the t squared term is 1/2 a. So 1/2 times a negative 9.8, that gives me negative 4.9 times t squared. It would be plus 0t, so there's no initial velocity in the y direction because for this calculation, this is going to be at an angle of 0. So at an angle of 0, there is no y component, right? It's a completely horizontal shot. Okay, so that means that the velocity in the y direction is equal to 0. So then all I have is my constant or my starting height, right? So y naught, that was 5, and I've reported that here as well. Then for my position equation, my x of t, that's equal to just my Vox, or VO in this case, right? Because we already established that it's completely horizontal velocity. So all the initial velocity, or initial speed, as we call it over here, that is in the horizontal. So we could call it VO, we could call it Vox. It's the same thing in this case, right? And we're going to multiply that by t final. There's no acceleration in the x direction, so we have no t squared term. And then our starting position, if we look back, we can see that our starting position is 0, right? This is where we started measuring from. It doesn't make any sense to give it anything other than 0 meters, and so we'll just set our starting position in the x direction as 0, okay? So if we go back, we can see that's all we would have for our x of t equation. So let's move on to what we need to calculate in table 2. So you can see that our next blank here is average range x final. We don't have to calculate that. We can pull that directly from table 1. So if we go over to table 1, we can see that our average is 9.17. So I'm just going to copy that. And then paste special, I'm just going to paste it as a value. So that's the little clipboard that has the 1, 2, 3. That way it doesn't have any equation links to it and nothing funky happens with Excel. So now we have 9.17. That was our average range value. So now we're ready to calculate the initial speed using our average range. So the first thing that we're going to do is we're going to solve for t final using our y of t position equation. So we're going to set y of t equal to 0, and we're going to solve for t. Okay, and that's going to give us t final. Now, if you're wondering why that is, if we look back at our canon, right, well, we know that this is x is equal to 0. So in the horizontal, this position here is x is equal to 0, but the ground is y is equal to 0. So when we fired that projectile, right, this position here is y is equal to 0. So if we set our position equation, y of t equal to 0, and we solve for t, that will give us the time that this object hits the ground. Okay? So that's what we're doing. So you can see from this equation here we have negative 4.9 t squared plus 5. So what we're going to do is we're going to move our 4.9 to the other side of the equal sign. So now it becomes a positive. So then we would have 4.9 t squared is equal to 5. Then we'd have to divide both sides by 4.9 and then take the square root. Okay? So in other words, in Excel lingo, that would be equals square root of 5 divided by 4.9. Okay? And we get 1.01. All right? And this is t final. Okay? Now we move on to the next part of solving for VO, and that's using the x of t equation, right? So what we're going to do in this case is we're going to set our position equal to the range, right? X final. That way we can use t final. So then we have one equation and one unknown, and we just solve for VO, right? Our initial speed, our calculated initial speed. Okay? So essentially what we're going to have is we're going to have x final on this side of the equal sign equals VO times t final, which we just solved for here. So if we rearrange that to solve for our unknown, which is v naught, or our calculated initial speed, we would have x final over t final, right? Because we'd have to divide both sides by t final to get VO by itself. So in Excel lingo, that means we're going to be taking B2, right, which is x final, divided by J1, which is t final, and that'll give us VO. Okay? So you can see right here that VO is equal to 9.07. So 9.07. Okay? The last thing that we need to do is calculate percent error, which we've done plenty of times before. So that's just equals 100 times, and we're going to take the absolute value of our actual value minus our calculated value, or our experimental value, divide that by our actual value, which is D2, and then that's it. So that's our percent error. Now you'll notice in this table, yes, I did ask for percent error, and if you look at the instructions, you can see that the example table has percent difference. I did that deliberately because the actual initial speed is the actual value. So to me, it makes more sense to calculate the percent error rather than the percent difference. However, if you calculate the percent difference and if you calculate it correctly, I'm not going to take off points for that. But I would prefer if you calculate the percent error like I have here. All right. So as far as rounding is concerned, I think rounding out to the hundredths place is good. If you feel uncomfortable doing that because you see that you have a 5 and a 10 and nothing in the decimal place, and since you know that you're using height when you're calculating t final and then ultimately this, so your calculations for this and this should both have no decimal places, I'm totally cool with it if you want to report everything except for this as having no other decimal places, so rounding off to the nearest whole number. But I'm also totally fine with you reporting it out to the hundredths place. As for table 1, uh, because you're using the measuring tape, if we go back and look at this, if you're using the measuring tape, you can see that it does go out to those 2 decimal places. We do know that precision for our measuring device, so these should definitely all be out to the hundredths place. But all right, so that's pretty much it for Lab 4. Remember that it is a formal report, so make sure that you look at the formal report checklist. So whichever section you are, your Blackboard for your lab section will look exactly the same. And for remote, you're going to click on the remote rubric and you'll go to requirements for formal report 4. Okay? Make sure that you take a look through it. Make sure you answer all of the bullet points. You should not be writing, and I do say this for a few of the sections. I may have forgotten on a few. No bullet points. This is a formal report. I do not want to see bullet points. All right, well, that's pretty much it. So, best of luck, and I look forward to seeing your reports.